Lesson 2.6 is called mixture problems. And I'm going to teach you a very specific way that you're going to set these up to help you just set up your equations correctly. You're going to actually use a chart. And you're going to need to memorize this chart. It's the same format for the different types of mixture problems you see. The only thing is sometimes the title changes and then where you're filling in the information is going to change. But as you get used to these, using that chart will help you a lot. You're not actually going to have any of these on your test. I'm introducing them to you now so that you can practice them, and we'll see them throughout this whole semester, and then you'll be tested on them at the end of this semester, first semester. But you still need to make an effort to learn them now so that you have time to learn to get better at them before the test comes up. That will include them. So let's go ahead and make a left side because you are going to write some stuff. First thing, you're going to set up a chart every time. And I'm going to go ahead and just give you the first example so that I can show you how to set up the chart with an example. So this is example 1. Raisins cost $2 per pound. And nuts cost $5 per pound. How many pounds of each should you use to make a 30-pound mixture that costs $4 per pound? On your assignment, you're not going to need to write this whole entire thing out, but for your notes, definitely write them out so that you have something to go with it. On your assignment, you're just going to make the chart and fill in information from there, and some of you might even end up wanting to write down some key info. So let's go through here and just read and stop and think about what things look like they might be important in here. So I know a lot of you probably noticed raisins being $2 a pound are important. Nuts being $5 a pound are important. 30-pound mixture is important, and the cost of it is important. These are extremely useful in a lot of sciences, and then sometimes in the business world, people are trying to figure out how much it costs to make these different things, and then they want to think about how much to mix because they might have noticed here, if someone was to put in too many nuts, then the cost is going to get more expensive since nuts are more expensive than raisins. So you're looking at balancing those out. That's the whole point in being able to figure out these mixture problems. Okay, so here's how you're going to set up your chart, and you're going to do this every time. Again, only thing that might change is the title in the top of the column. You're going to have a chart that's going to have one row for each item you're mixing, and then a final row that's a mixture. So I'm just going to set up a little version of it here. Item being mixed, mixture. Okay, every time. You might have more items. You might have another item here. Doesn't matter. All that matters is that your items go first, your mixture goes last. It's going to make life a lot easier that way. Up here, you're going to end up filling in your I want to say your amount, but I don't mean in cost. I mean weight or how much you have. Okay, sorry, that says how much you have. here, you're actually going to be writing in the cost, how much it's worth. And I'm going to go ahead and put or percent here, because the other kind you're going to see is a percent. So you're always going to be talking about the weight or the volume or how much of it there is, and then you're going to be talking about the cost or the percent of it. And then here you're going to have your totals, equals, equals, equals. And we'll talk about what to do with those totals. Okay, so let's go ahead and fill that in here. So I have raisins, nuts, and my mixture. I'm going to talk about my weight. And then I'm going to talk about my cost and money. And then this is going to be my totals. So now we just need to start filling in information that we've been given. So go through. So first you're going to fill in given info. So I look through here, raisins, $2 per pound. So I go to cost and I fill in $2. Nuts, $5 per pound. Cost, $5. A 30-pound mixture, so there's my mixture, that's 30, that costs $4 a pound. Every time you do this, you should have 2 empty spaces. You're going to fill those in, and I shouldn't say every time. Sometimes they actually give you one more piece of information here, which makes your life even easier. But typically, the more difficult ones are going to have 2 empty spaces. So you fill in those spaces based on one variable. You don't get to call them X and Y. You need to figure out one variable, fill them both in here. Now, this is why you need to have the mixture at the bottom. You need to think about this. Everyone just stop and think for a minute. If I was to tell you that I put in 5 pounds of raisins, how many pounds of nuts would you tell me I put in? Most of you should have said 25 pounds, because 5 plus 25 is 30 here. Or you took 30, you subtracted 5, you got 25. What if I said 10 pounds of raisins? Well, then you probably have 20 here. 30 minus the 10 is 20. What if I said 15? 15 pounds of raisins. Then I'd have 30 minus 15 and I'd get 15. If I said 20 pounds of raisins, 30 minus 20, I'd have 10. So the pattern there is that these two add up to be the mixture. Or you can think of it in these terms. The mixture subtracting one of them gives you the other. The mixture subtracting whatever you're going to put in here gives you that. So this is what these should look like. I'm going to call this R. Someone else might have decided to use N, but I'm going to go ahead and use my first one, which is R, and then I stop and I think about it. Now don't reverse these. It's not R minus 30. It's whatever this is going to get subtracted from 30 to give me N. So this becomes 30 minus R, my raisins. Really important you don't flip those around. It's 30 minus whatever that is to give me that. Okay, every once in a while, including on tomorrow's assignment, they're going to give you one of these and they're going to ask for the mixture. If that happens, you need to think about the opposite. Let's say this was 20 and I was adding into it. 20 plus n equals whatever my mixture is. So on that case, when you're missing your mixture weight, you're just going to add these two together. All right, now to get your totals columns, you're just going to multiply. Hopefully, most of you noticed I put this in parentheses. The reason I put this in parentheses is because when I multiply, what am I going to have to do with that 5? That's right, I'm going to have to distribute. So I just multiply across. 2 times r is 2r. Remember, coefficient always goes in front. 5 times 30 is 150. Subtracting 5r. And if you want to keep that in parentheses, you can. 30 times 4 is 120. So now over here, multiply across each row to get totals. Once you have these totals, if you think about it, all this plus all of that is going to equal my mixture every time. So now add the totals of items being mixed and set equal to mixture total. And you're going to do that every time. Whatever's in here adds to whatever's in here equals the mixture. Another reason we put the mixture at the very bottom, because you don't want to have to be trying to figure out which one it is later. So this is your equation that you're setting up. So it should look something like this. 2r plus 150 subtracting 5r equals 120. And notice positive being distributed here, so nothing's going to change, so I really didn't need that. Now you're just going to follow what you've been doing with equations. 2r subtracting 5r is a negative 3r plus 150 equals 120. And then you subtract 150. Be careful with your signs here. Positives and negatives are so important. This is 150 minus 120. It's a difference because you have opposite signs. The difference between 120 and 150 is 30, but my negative is the one that won out because it was the larger. Now I divide by negative 3. You should never have a negative answer in the end of these, so if you do, you know you made a mistake. R equals a negative divided by a negative is a positive. 30 divided by 3 is 10. Now you need to stop and ask yourself, what did I just find? And you notice here you found R, which is raisins. It wants us to find how many pounds of each should you use. So we found pounds of raisins. We need to go plug them in here. 30 minus raisins equals our nuts. So 30 minus R, which is 30 minus 10 equals 20. And that's our N. Which means you need 10 pounds, remember you always label, of raisins and 20 pounds of nuts. I know this seems like a lot and it's pretty overwhelming. That's why we're going to give you some time to learn it. But I just want you to remember that this is going to be the same pattern every time. So when you go to do the work, really memorize how to set this up, because that's going to be key to making all of the mixture problems you come across so much easier. All right, I'm going to show you an example of the other type that you'll come across. You still use the same chart, but we're going to use percents instead of cost. So this one says, we'll use this as example 2. A chemist needs a solution that is 75% acid but only has solutions that are 35% and 85% acid. If the chemist measures 120 milliliters of the 85% solution, how many milliliters of the 35% solution should she add to make a 75% solution? Go ahead and hit pause and finish writing that, and then when you're ready, hit play. All right, so this looks really confusing because you're using these 35, 85, 75 over and over and over. But here's the really nice thing about it. That's the name, that's the item. So you just go through and you look, okay, a chemist needs a solution that is 75% acid. So the total needs to equal the 75%, but has two solutions that are 35 and 85. So these are the items that are going to be mixed. If the chemist measures 120 milliliters of the 85%, how many, there's your key, how many milliliters of the 35 should she add to make a 75% solution? Making it means that's the mixture. These are what are being mixed. So just be very aware of that, because this is going to be set up a little different. So we go ahead and we figure out, okay, how many things am I mixing? I'm mixing two things, where'd they go, there and there, and I have a mixture. So I need 3 rows. And now I'm going to write them down. So what am I mixing? I'm mixing, it says, an 85% solution and a 35% solution. So this is our 85% solution. This is our 35% solution. The mixture that we want, and you might even want to put mixture, is our 75% solution. So now you're going to set up your 3 columns. Remember, your last column is your totals. This is talking about how much of it you have. So your weight or your volume. This is talking about either your cost or your percent. And in this case, it's a percent. We don't have a cost. Notice the chart's exactly the same here. The volume or the weight is going here. The percent of the cost is going here. Your items and your mixture. Now, the only thing you have to be aware of when you're filling in here, you already have your percents. This one is 85%, but you need to write it as a decimal every time. So this is 0.35 and this is 0.75. That's how easy that should be to fill in every single time. You just convert those to decimals. So make a little note over here. Convert percents to decimals when you're filling them in that chart. Now you need to go try to find what else you've got here, because remember, we should only have 2 empty ones, and right now we have 3. Right here, 120 milliliters of the 85% solution. There's my 85%, so I'm going to fill in 120 there. This is the kind where I was talking about. This mixture plus that mixture, or this solution plus this solution being mixed equals that total. So you don't have to subtract when you're missing this bottom mixture. This one could just be called X, or whatever you want to call it. It could be a T for 35. If I add those two up, I should get that. So this time, we actually end up with that type of equation. And it doesn't matter if you have X plus 120 or 120 plus X. Commutative property. So now you're going to go through and you're going to multiply those out. This is one where you want to go ahead and just use your calculator, save yourself some time. So we have 120 times 0.85 or 85 hundredths, and we get 102. We have 35 hundredths times X, which is 0.35X. And then remember, you're distributing this. It's 0.75 times 120, which is 90, but don't forget the rest of it, plus 0.75x. If you need to, keep that in parentheses if that's going to remind you to distribute this to each of those. So don't forget to distribute. I'm actually going to go like this so that you have it in your notes, just in case you forget. Okay, now remember, this total plus this total equals the mixture's total. And you're just going to set it up exactly like that. So I have 102 plus 0.35x equals, and now I can drop my parentheses, 90 plus 0.75x. And I'm going to go ahead and solve. Let's practice a decimal buster here. You don't have to use it, but let's just practice it so that, because there's a couple options here, I shouldn't say options, there's a couple opportunities to accidentally make a mistake, so it's good to see. I'm looking for 2 places back because those both have 2. I need to add 2 places back to every term. 1, 2, 3, 4 terms. So I have 102 becomes adding 2 zeros. 0.35 becomes a 35x. 90, I have to add 2 zeros. And then plus 75x. Completely up to you, but that's the way that you're going to do that if you don't want to have any decimals. You have to remember to change these also. You can't just drop it there. So now, because I like to keep things positive when I can, I noticed that 75 is larger than 35, so I'm going to go ahead and move. So here you're going to subtract 35x from both sides of the equation to move the variable to one side. You still have 10,200 left on your left side, and then you have 9,000 on the right, and you have opposite signs here, so make sure you subtract 40x. positive 40x. Now you're trying to isolate this variable, so don't worry about the fact that it's on the right. Just follow all the rules we've been using, which is move the terms without the variable over first. Once you subtract that, you have 1,200 equals 40x. Now you're still solving for x, so you're going to divide both sides by 40. And once you divide 1,200 by 40, you end up with 30. So 30 equals x. Once you have this, you need to stop, think about what you just solved for, so go back up to your chart. 30 milliliters is what you have of your 35% solution. Now you need to go read your question, and it says, how many milliliters of the 35% solution should she add? So that's all they're looking for. They're not looking for the total milliliters here. You already solved for x, which was the 35%, so your answer is she should add 30 milliliters of the 35% solution. And you could go further if you wanted to get a 75% mixture, but I just want to know you answered the question that was asked. And that's mixture problems.